So get out that homework assignment. Oops, 8.1b. 8.1b homework review. It was, I believe, page, let me check here. Page 587. 587. Numbers, I said 79 through 111 odd. Is what I said. So which questions would you like me to review? Look at the homework. Pick which questions you'd like me to go over. Any particular ones people needed help with? Look at that homework. Look at those assignments. 91, 93. Sure. 91, 93. We can do that. 91, 93. It said to use a graphing calculator. That just means add them up together. So 91, 93. Any other ones from this list here? Again, we're going to use a lot of calculators for this to add up all these numbers together. Use whatever calculator you've got. What about something from that next group? 95, 99 maybe, 101. Let's do maybe 101. Do 101, and then I'm going to do 105. One from kind of each group. So let's work on those. And then maybe I'll do 109. All right, so let's go through these quickly. The goal here for summations, remember what we have is we have this symbol here, which means, which is sigma. This is the Greek letter sigma, which means add up all the terms. We introduced you to this new Greek letter sigma, and you have some equation here, and we go from that equation from 1 to some value here, right? I guess that should be an I. So this Greek letter sigma indicates that we're adding up all the different items in this sequence. Right, we're going to get A1 plus A2 plus A3 plus ... all the way up to AN. And we're going to add up, right? The sum here, the sigma, means we're adding up all the numbers in the list that we make. So you're plugging in 1, 2, 3, right? You're plugging in 1, 2, 3, 4, all the way up to N, and then you're going to add them all up together. So let's look at 91. 91 says, I want the sum, sigma, from J, we use the letter J here, they use all kinds of letters, from 1 to 6, of the equation 24 minus 3J. And they want the answer of what this sum is equal to. That's what we're doing. Roberto, welcome. Make sure you say hello in the chat. So all you do is you're going to plug in the numbers 1 to 6 for J, right? So J, you're going to get 1, 2, 3, 4, 5, and 6. Plug them into this equation here. Plug them into this equation. Right? Plug in the 1 for J. That's a J here. Plug in the 1 for J, 2 for J, 3 for J, and then calculate what that number is, and then add up all the pieces. So if I do a 1, it's going to be 24 minus 3 times 1 for the first term. 24 minus 3 times 1. So that's 24 minus 3, that's 21. Plus the next one, 24 minus 3 times 2. 3 times 2 is 6. 24 minus 6 is going to be 18. So 21 plus 18. Plus, again, I do it again, 24 minus 3 times 3. 3 times 3 is 9. 24 minus 9 is going to be 13. 15. And I keep going. 24 minus 3 times 4 is 12. 24 minus 12 is going to be plus 12. And then 24 minus 3 times 5 is 15. 24 minus 15 is going to be 9. 24 minus 3 times 6. 3 times 6 is 24. 18. So that's going to be 24 minus 18 is going to be 6. So 21 plus 18 plus 15 plus 12 plus 9 plus 6. I'm adding up all these numbers together. And that's going to be 81. Yeah, 81. And that's it. That's how we do these problems. We just plug in the numbers, right? We plug in the numbers from 1 to 6 into this equation here, get the values, and then add them all up. Plug this in a calculator, 21 plus 18 plus 25, all these things up to the last one, numbers up to the 6th term, because that's where it ends on the 6th item, and then add them up. Yeah? Pretty straightforward. Same happens with 93. Let's just do this again quickly, 93. Again, it wants the sum from k equals 0 to 4 of negative 1 to the power of k over k plus 1. So we're going to plug in the different k's. We're going to have our k be 0, 1, 2, 3, and 4. And then we're going to add up all those numbers. So let's see, we have negative 1 to the 0 power over 0 plus 1. Well, negative 1 to the 0 power is 1. 0 plus 1 is 1, so that first term is a 1 over 1. And then same thing here, negative 1 to the power of 1 over 1 plus 1. Negative 1 to the power of 1 is negative 1, so it's negative 1 over 2. Negative 1 squared over 2 plus 1, so negative 1 squared is positive 1. Over 3, and just keep going. This is going to be 3 plus 1, this is going to be negative 1 cubed is a negative 1, 3 plus 1 is a 4, and negative 1 to the 4th, negative 1 to the 4th power over 4 plus 1 is going to be positive 1 over 5. So add up these together. You can use a calculator. So this is going to be 1 minus a half plus a third minus a fourth plus a fifth. Yeah? 1 minus a half. So that's a half plus 1/3. That's going to be maybe what? That's going to be, I can make a common denominator of 6. So 3 over 6 plus 2 over 6 is going to be 5 over 6 minus 1 over 4. Okay, now I need to find a common denominator between 6 and 4. On and on. Or use a calculator. You're going to get the answer is 47 over 60. Your fraction there. If you got a decimal answer, that's okay too. I would prefer fractions, but decimals are fine. Question? All right, so that's how you do these problems. You enter the numbers, you plug in the values, and then you add them all up. Next I said 101. In the next group, they don't give you the equation. They just sort of show you a pattern, and they want you to add it up together. So 101 is 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus dot dot dot. And they end on, oh, I'm sorry, it's plus minus, so it's going to be minus here, then plus, then minus, dot dot dot. They end on minus, this is 1 over 4 squared plus dot 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 minus 1 over 20 squared. So what I would do in this problem, clearly they want to go from 1 to 20 on the bottom, switching between minus and plus. minus, plus, minus, plus, minus, plus, minus, until they get to minus 1 over 20 squared. And what I would do here is plug into a calculator. Just plug this into a calculator. There's lots of calculators online. You can do Desmos is a good calculator. It has a calculator option, not only graphing but also can do calculations. Let me show you what happens here. If I was to do this in Desmos, 1 over 1 squared, minus 1 over 2 squared. See how it gives me the answer down there. Plus 1 over 3 squared, minus 1 over 4 squared, plus 1 over 5 squared, minus 1 over 6 squared. You would just keep doing this until you get to 20. Plus 1 over 7 squared, minus 1 over 8 squared, plus 1 over 9 squared, minus 1 over 10 squared. You see what I'm saying? Just plug it into a calculator, get your answer. Overall, let me see if I have the answer here for this 101. When you get this answer sort of finally figured out, you're going to get something that's close to, you see it's like 8.179. It's going to get about equal to 8.2. It's going to be about equal to 8.21 something, right? So it's about equal to 0.821 dot dot dot. There's more decimals there, but approximately, right? Show me the decimal. If you want to make it a fraction, I mean, you're welcome to. It's going to be a crazy fraction, but decimal's probably a little easier. So plug that into a calculator. The same thing for all the rest of those. Get yourself a calculator, plug in those answers. Okay, 105 and 109. 105. So now we're talking about infinite sums. We talked about finite sums. Finite is when you have a starting number and an ending number. This is a finite sum. But oftentimes in this situation we have infinite sums where we start at 1 and we go to infinity. Right? The sum never ends. And this one is 5 times 1/2 to the power of I. And if we were to try to find the sum of this, we don't know the tools yet, but we're going to learn how to do the infinite sums. We can actually get a number of an infinite sum here. It's pretty amazing. You can add up an infinite number of things and get like an actual number, which is crazy to think about. But instead, it asks us to find the fourth partial sum. And what that means is we're just going to go four places. We're going to go I equals 1, 2, 3, and 4, and add up those together. Fourth partial sum just means I want 4 pieces. So 5 times 1/2 to the first power, plus 5 times 1/2 to the second power, plus 5 times 1/2 to the third power, plus 5 times 1/2 to the fourth power. Again, plug into a calculator. You're going to get your answer, 75 over 16. So this whole process, you're just adding numbers together, one after the other, in this pattern, using these patterns. And again, following these patterns, one of the most fundamental types of mathematics we can do, recognizing where these patterns are. So, and the more patterns that you see, how they work, right? You see these processes here. This is a 1/2. It's getting smaller and smaller as we go along. Interesting little pattern. And the last one, 109, one of those interesting patterns, an infinite series. I had I equals 1 to infinity. This one I wanted you to do 6 times 1 over 10 to the I. And this was a special pattern. We talked about this last class when you have this 1 over 10, when you have this 1 over 10 number. If you add up an infinite number of these, it's going to be, again, eventually it's going to be 0.666 repeating. This 1 over 10 means it's going to be 0.6 and then 6 again, and then 6 again, 6 again, 6 again, on and on and on forever. Because the 1 over 10 changes the decimal place where we are. So when we have this 1 over 10, it means the answer is going to be 6 over 9, which we simplified to be 2/3. And if you divide 2 divided by 3, you get that infinite decimal of 0.666 repeating, right? So this is your answer for that one. It wants the, what does it say? It wants the fourth partial sum. So 1, 2, 3, 4. This is your fourth partial sum. And this is the actual answer, right? So whenever we have this 1 over 10, it creates a fraction of 1 over 9. And the 6 is the top number. So 6 times 1 over 10 to the I becomes 6 over 9, which is 2/3. So a little trick with this 1 over 10, it creates this fraction of 1 over 9. Again, a very strange process why this happens. How does 1 over 10 become 1 over 9? It's just a weird way. When you go to infinity, that's what it becomes. When you go to infinity, 1 over 10, added up all together, becomes 1 over 9. Very strange process here. So real quick introduction to these problems here. If you haven't done this yet, again, all you're doing, get yourself a calculator, add up all these numbers together, get your final answers here. Here's our answer here. Add these up together and see what you can get. And again, a couple little tricks you need to know about. This infinity one, where you have 1 over 10, becomes a 1 over 9. And then the number in front becomes the number on top. So this has 6 times 1 over 9 is 6 over 9, 2/3. All right? Are we okay with that, everybody? Any other questions on this assignment? Anything else missing? So I want to get into these notes today for our next topic. It's okay? All right, let's get into this next one, see what we can do.